Well, this video is for Math 70, and this is for the first assignment on trinomial factoring. We'll look at this kind of factoring over a series of 3 assignments. And just like in the greatest common factor factoring, trinomial factoring undoes a multiplication. It's the opposite of multiplying. Okay? So we had seen how if we multiply 2 of these expressions, like x plus 5 times x plus 7, first we distribute the x to give us x squared plus 7x, and then we distribute the 5 to give us 5x plus 35. Combine our like terms in here, and that gives us x squared plus 12x plus 35. Now, what's interesting about this, and what we're going to be looking at to go backwards in the factoring process, is that this number in the middle, 12, is 5 plus 7. 5 plus 7, all right? And this last number here, 35, this is 5 times 7. And that's really at the heart of this concept of trinomial factoring. So, we're always going to, in this first assignment, this sign will always be plus. And so what we're going to be looking for is numbers that multiply to give us this last number and add up to give us the middle number. Okay? Now, we can do a similar idea if we have, let's say, x minus 4 times x minus 6. So here's our x squared minus 6x minus 4x and then plus 24. Okay? And then again, combine the like terms in the middle, and we get x squared minus 10x plus 24. Now notice that this sign right here is still positive because you had minus times minus to give you a positive. And also notice that the 10 in the middle is still 6 plus 4. You can think of it as negative 6 minus 4 if you want to, but it's not important whether you think of it as minus 6 minus 4 or 6 plus 4. And then this, again, of course, is 6 times 4, or negative 6 times negative 4. All right, so that's always what we're going to be looking at to do these problems, because the problems are going to take us in this direction. They're going to take us back from this expression, which has 3 pieces. That's what the tri and trinomial means. We're going to take it from this expression back to the product of these 2 parentheses. Okay? So, let's take a look at a couple problems and see how these work. Okay, let's see here. Problem 2, y squared plus 9y plus 8. So, we want to set this up so that we've got y times y here to give us that y squared. And we want factors of 8 that are going to add up to 9. Okay? So, 1 times 8 or 2 times 4. So we want the 1 times 8. 1 times 8. And this is a positive 9, so that tells us we want plus and plus. And we're done, essentially. I mean, we can check by saying, oh yeah, there's the y squared, there's the 8y, there's a 1y, and then there's the 8. And yeah, that does give us y squared plus 9y plus 8. Okay, let's see here. Let's look at problem 4. Here we've got a squared minus 10a plus 16. So we're going to split it into 2 pieces. We're going to have a and a in the front. And then in the back, we want factors of 16. You could have 1 times 16, 2 times 8, or 4 times 4. But we want the pair that's going to add up to give us 10. So that's the 2 and the 8. And notice that this is minus 10. So we want minus 2 and minus 8. All right? So that's how these problems work. Let's look at a couple more. Let's see here. Well, let's look at number 10. See, we've got a squared minus 12a plus 40. Okay, so we want the a's there. And then we want to know, well, what are the possible factors of 40? 4 times 10, 5 times 8. And I think that's about it. Let's see, do any of these add up to be 12? You get 13, 14, 22, and 41. So, just like we saw on that previous assignment, there are sometimes polynomials that are prime, just like there are prime numbers, there are prime polynomials. And this is an example of one. Now, I don't put these on quizzes and tests because people just get lazy and they say that they're all prime because they're too hard to factor. So the ones that I put on quizzes and tests, you will be able to factor those. Okay, so don't give up and just try to tell me that they're prime. Let's see here. Problem 14. You've got x squared minus 22x plus 72. All right. So there's our x and x. And now we need to know the factors of 72. And all I do is I go through 72 divided by 1, divided by 2. Now if you're not sure, do 72 divided by 3. You should get 24. 72 divided by 4 is 18. And 72 divided by 5 is not a whole number. 72 divided by 6 will give you the 12. And then that last pair is 8 times 9. So these would add up to 17, these would add up to 18, these would add up to 22. Those are the ones we want. Here they are right here, 4 times 18. So we want x minus 4 and x minus 18. And that'll give us x squared minus 22x plus 72. All right, let's see here. What else? Let's see here. Well, let's look at the ones on the bottom. Problem 20. We get y squared plus k times y plus 10. And the instructions say find positive whole numbers for k which make this trinomial factorable. So what we're saying here is that if that value for k is the sum of two factors of 10, then this will be factorable. So if this were, let's say, k equals 11 or k equals 7, y squared plus 11y plus 10, that's y plus 10 times y plus 1. Or y squared plus 7y plus 10, because that's y plus 2 times y plus 5. So all I'm looking for here in the answer is just k could be 11 or 7. But this is why k being 11 or 7 makes that expression factorable. All right, let's look at another one here. Problem 22, m squared plus km plus 18. So, what we want to do is look at the factors of 18. 1 times 18, 2 times 9, and 3 times 6. So, this would be 19, this would be 11, and this would be 9. So those are the possible values for k. K could be 19, 11, or 9. And so, if k is 19, then you end up with this expression, which is factorable. Let's see, if k is 11, then you can factor it as m plus 2 times m plus 9. And if the k is 9, then you can factor it as m plus 3 times m plus 6. Okay? All right. Let's see here. Let's look at 26 and 28, which are kind of interesting. Because here we're still looking for values of k, but now the k is the last value in the expression. So 26 says y squared plus 7y plus k. Y squared plus 7y plus k. All right, so what's going to make this factorable? Well, we need a couple things that are going to add up to give us 7. So you could have 1 plus 6, and that means k would be equal to 6. You could have 2 plus 5, which would make k equal to 10, or 3 plus 4, which would make k equal to 12. Okay, so those are our answers. K could be 6, k could be 10, or k could be 12. So let's look at an example. If the k is 12, then we would get y plus 3 times y plus 4. So that's what I was looking at the 7 here and breaking it down, and then looking at the product. The 3 times 4 gives you 12, 2 times 5 gives you 10, and the 1 times 6 gives you 6. All right, let's look at 28, and then that'll be it for this assignment. So 28 is x squared plus 9x plus k. X squared plus 9x plus k. So we do the same thing we did over here. We could have 1 plus 8, 2 plus 7, 3 plus 6, or 4 plus 5. After that, we're just using the same numbers over again. So this would give us k equals 8. This would give us k equals 14. This would be k equals 18. And this one would be k equals 20. And then those are all our possible values for k. For example, in this one right here, x squared plus 9x plus 20, that means this would factor as x plus 4 times x plus 5. Okay, so that's it for this first assignment on trinomial factoring. We'll follow this up with 2 more assignments that get into the same concept. As always, if you have any questions, please let me know. Thanks.